During the Neolithic period, obsidian became one of the most valuable materials in the ancient world. This natural volcanic glass is sharp and durable, which made it ideal for tools. Archaeologists have discovered obsidian artifacts at many archaeological sites across Europe. But there's one small problem with this. Natural sources of obsidian are actually not that plentiful. This implies that it was transported over vast distances, requiring some level of coordination. One interesting study examined 3 obsidian blades found in Poland and revealed that they had originated from a dormant volcano in eastern Turkey over 2,000 kilometers away. What these blades reveal adds to the growing evidence that people in prehistoric Europe were connected through surprisingly vast networks of travel, trade, and cultural exchange more than 6,000 years ago. Most obsidian tools discovered in Poland date to the early Neolithic, particularly during the time of the linear pottery culture between roughly 5300 and 4900 BCE. However, obsidian artifacts are known from even earlier periods, including the Paleolithic and Mesolithic. During the Neolithic, this volcanic glass was highly valued for producing exceptionally sharp blades and tools. Its use continued throughout the Middle Neolithic before gradually declining during the Late Neolithic. One of the most useful properties of obsidian for modern archaeologists is that each volcanic source possesses a different chemical signature. By analysing the elemental composition of an artifact, researchers can determine where the raw material originally came from. Earliest obsidian finds in Poland were traced to sources in present-day Slovakia and Hungary, suggesting regional exchange networks were already in place. But by the Neolithic, these networks appear to have expanded dramatically. The recent study focused on 3 unusual obsidian blades. 2 were excavated from the Neolithic settlement of Racibórz-Ocice, while a third originated from an unknown site somewhere in Silesia. Establishing the provenance of these artifacts is crucial because the study's extraordinary claim that the obsidian travelled across much of Europe depends on confirming that the blades genuinely belonged to Neolithic contexts in Poland. Racibórz-Ocice is located on a terrace overlooking the Oder River in what is now southwestern Poland. Archaeological excavations at the settlement took place during the late 19th and early 20th centuries. In total, 55 obsidian artifacts from the site have survived to the present day. Most are housed at the museum in Wrocław, while smaller groups are kept in the museums of Racibórz and Gliwice. The 2 blades examined in the study are distinctive because of their unusual greenish-grey colour. Although researchers still debate the exact circumstances under which these artefacts entered the Museum of Gliwice, the available evidence strongly indicates that both were excavated at Racibórz-Ocice and had entered the museum collection before 1930. Based on associated pottery from phase 4A of the stroked pottery culture, the blades are believed to date to between 4900 and 4800 BCE. The third artifact, also made from greenish-grey obsidian, was discovered sometime between 1961 and 1970 at an unknown location in Silesia. Today it is displayed in the Archaeological Museum in Wrocław. Previous chemical analyses of the obsidian artifacts from Racibórz-Ocice, particularly those housed in Wrocław, showed that they originated from the Zemplén Mountains in southeastern Slovakia. But when researchers analysed the 3 greenish-grey blades, they uncovered something completely unexpected. The obsidian had come from a source far beyond the traditional Neolithic trade networks of Central Europe. One of the blades from Racibórz-Ocice measures around 4.4 centimetres in length. Researchers believe it was produced from a single platform core using a pressure flaking technique. A microscopic examination revealed traces of use along its cutting edges. The second blade is much smaller, measuring just 2.1 centimetres long, but it too appears to have been crafted using pressure flaking and shows wear marks along the left edge on both sides. The third artifact is particularly interesting. Although incomplete with its tip missing, the surviving blade section still measures around 6 centimetres in length. Technological analysis suggests it may have been produced using a knapping technique more commonly associated with Southwest Asia rather than Central Europe. Researchers also studied patterns of wear on the artifacts. Some of the marks appear consistent with cutting soft materials, such as animal hide, while others may relate to hafting tools from organic materials. However, because the artifacts have passed through museums and collections for more than a century, the authors are cautious about drawing firm conclusions from these traces alone. Even so, the researchers are confident that the two blades from Racibórz-Ocice genuinely belong to a Neolithic context. Based on technological similarities, they also believe the third Silesian artifact is probably Neolithic, although its exact date remains uncertain. But the most significant part of the study involved determining where the obsidian itself had originated. To do this, researchers analysed the chemical composition of the three artifacts, measuring elements including aluminium, rubidium, strontium, yttrium, zirconium, niobium, barium, iron, titanium, and manganese. They also generated iron to manganese ratios. They then compared the results with samples from volcanic sources across the Mediterranean, the Carpathians, Armenia, Georgia, and Turkey. The results pointed overwhelmingly towards one location, the Nemrut volcanic province in eastern Turkey, most likely the dormant volcano known as Nemrut Dağ. This means the obsidian had travelled more than 2,200 kilometres before eventually reaching Poland, making these the westernmost known artefacts ever traced back to that volcanic complex. Archaeologists already know that Neolithic communities in Silesia in modern-day Poland maintained connections with groups living far to the south in the Tisa basin of present-day Hungary. Evidence for these interactions can be seen in similarities between pottery styles and ceramic assemblages found across the two regions. Researchers have also identified links between Silesia and the Cucuteni Tripilia and Lengyel cultures through the discovery of distinctive clay figurines and ceramic rattles. Together, these finds suggest that ideas, technologies, and cultural traditions were moving across surprisingly large parts of prehistoric Europe. There are also several remarkable discoveries showing just how extensive these long-distance connections became during the Neolithic and Copper Age. At a Cucuteni period site in Romania, archaeologists uncovered an obsidian artifact whose source was traced to the island of Melos in Greece, demonstrating that exchange networks stretched from the Aegean deep into Eastern Europe. In Poland, richly ornamented Mediterranean seashells have been found in burials nearly 2,000 kilometers from the coast, implying that these exotic objects were highly valued prestige goods. Studies of Neolithic jade artifacts also point towards large-scale networks linking distant communities across Europe. Obsidian itself appears to have traveled extraordinary distances. Apart from the example from Melos in Greece, at an early Copper Age site in Hungary, researchers identified a blade made from obsidian sourced to Nemrut Dağ in central Turkey, proving that the volcanic glass could move across vast regions through interconnected exchange systems. But the recent Polish study pushed those limits even further. Before this research, the westernmost known obsidian artifact, traced to the Nemrut Dağ volcanic complex in eastern Turkey, had been found at the famous Neolithic settlement of Katılhoyuk, roughly 660 kilometers from the source. The Polish blades, however, were discovered more than 2,000 kilometers away, expanding the known range of Neolithic obsidian exchange. Exactly how the obsidian reached Poland remains uncertain. Since obsidian from Nemrut Dağ has not yet been identified at intermediary sites between Turkey and Silesia, the possibility of relatively direct exchange cannot be ruled out. It's also possible that groups moving westwards during the Neolithic carried the material with them over generations. The blades may have circulated through gift exchange, elite networks, or social alliances, gradually passing from community to community across Europe. Researchers also cannot determine whether the obsidian arrived in Poland as finished blades or as raw material later worked by local craftspeople. But regardless of the exact route it took, the discovery reveals something remarkable about the Neolithic world. Far from being isolated farming villages, prehistoric communities were part of expanding networks that connected distant regions through trade, migration, and cultural exchange. These obsidian blades are more than just ancient tools, they are evidence that people living over 6,000 years ago were interacting across continental scale distances in ways archaeologists are only now beginning to fully understand. Several years ago, an obsidian core was found off the coast of Capri that it's thought was once cargo of a Neolithic boat which had subsequently sank. I featured this in one of my videos. The discovery of this 8-kilogram chunk of worked obsidian being carried through the Mediterranean strongly suggests it was being traded as a raw material. More and more evidence keeps coming to light to reveal long-distance networks in the Neolithic. It makes me wonder, how did different groups communicate with one another, and how were these activities coordinated? Let me know what you think about our obsidian trading ancestors in the comments. Thank you for watching, and I'll see you next time.